Today we're going to be doing FRQ Topic 2. This is called Graphical Analysis, which involves heavily the fundamental theorem of calculus. Always no calculator. You can see the recent years that we have had these. It is on here every year. So the only year that we didn't see it was 2020, and really there we also saw it there. It was just in a completely different format. That was COVID year, so that was a very different year for FRQs. Okay. Alrighty. What you will see here, sometimes you're given that G is an integral of F and you're given the graph of F, or you might just be given the graph of G of a derivative, F prime, G prime, whatever, okay? Remember that if you're given G as an integral, you're going to need G prime, so that will be, you're using the second part of the fundamental theorem. We'll review that in a moment, okay? Either way, you're looking at the graph of the derivative of a function, and all of your questions will deal with that function. Okay, you'll use the graph to find increasing, decreasing, relative mins max, concavity, points of inflection, things like that. Okay. You'll also use the graph to find values of G. That will always involve fundamental theorem of calculus. You'll use signed areas under the curve. Don't forget it is signed areas, so any region that is below the x-axis will need a negative of that area, and so forth. Okay. If you're given G as an integral and you're asked to find values of G, you plug the given x value into the boundary. G of 2, integral, you put the 2 up here. G of 5, you put the 5 up there, etc. And then you do the areas. Okay. If you're given the graph of a derivative, okay, then you'll always be given at least one value of G. So if they don't give you the problem like this, if instead they just tell you this is the graph of G prime, then they have to give you a value of G if they want you to find other values of G. Okay, and you will set up fundamental theorem for that. Set up fundamental theorem. Okay. When you need to do the second part of the fundamental theorem is when you're taking the derivative of an integral. And this is the second part of the fundamental theorem, derivative of an integral. You start at the top boundary, plug it into your function, and multiply by the derivative. Okay. Minus. Do the same thing for the bottom boundary. Oftentimes the bottom boundary is a constant, and if the bottom boundary is a constant, then this entire part will be 0. Okay? For absolute mins and maxes, don't forget candidates test. Alrighty? Alright, let's do an example. We're going to do the example from 2023. We had a pretty decent KHS average. It's okay. It was higher than the global and the Texas, which is good. It was significantly higher, which is good, but usually on these types of questions, my students tend to do better than this. So something about this they didn't care for too much. Alrighty. It was number 4. This problem is always with no calculator. All right, f is defined on the closed interval from -2 to 8 and satisfies f of 2 is 1. The graph of f prime, consisting of 2 line segments and a semicircle, is given. So this is the graph of f prime. Part A. Does f have a relative min, max, or neither at x equals 6? Well, this is f prime. This is f prime. And f prime is positive on both sides of the 6. And if f prime is positive, f is still increasing, right? So f does not have either a min or a max there. So part A, f has neither a relative maximum nor a relative minimum. Since, what was our reason? We have to give a reason for our answer. These are always, all of these will reason, justify. Since f prime does not change signs at x equals 6. Okay? I probably should have said, I'm not erasing, I'm crossing out. F has neither a relative maximum nor a relative minimum at x equals 6 since. Okay. Alrighty, part B. So for part B, on what open intervals? They are telling you to write open intervals. So do not give them a closed interval if they say specifically open intervals. On what open intervals, if any, is the graph of f concave down? For f to be concave down, f double prime needs to be negative, true? We're given the graph of f prime. So we want for its slope to be negative. We want for the slope of the tangent lines to be negative. So from -2 to 0, and then again from 4 to 6. -2 to 0, and 4 to 6. I answered the question. Since, what did we do? What did we consider? The slope of f prime is negative. That's what we looked at. Another reason, a very good reason, would be since f prime is decreasing. Okay? You don't have to give them both. I'm giving you an option. The slope of f prime being negative means that f prime is decreasing. When f prime is decreasing, f double prime is negative. All right. Part C. So far, I feel pretty good about this question. Part C. Find the value of this limit, or show that it does not exist. As soon as I see a limit, I expect to use L'Hopital's rule. I expect it. Very, very rarely you won't have to, but in probably 98% of these questions, you have to use L'Hopital's on this one. And if it's an FRQ and L'Hopital's, you must show the limit of the numerator and the limit of the denominator separately. If you do not, you will not receive full credit for this. Okay, so we can do a quick check to see if it is L'Hopital's, 0 over 0. What is f of 2? F of 2 was given to us to be 1. So that would be 6 times 1 minus 3 times 2. Sure enough, that is 0. If we put 2 into the bottom, we'll have 4 minus 10 plus 6. That is 0. So we need to show that. The limit, see if I can get that in there. The limit as x approaches 2 of just the top, is 0. and the limit as x approaches 2 of just the bottom is 0. Therefore, L'Hopital's rule applies. You don't have to say that, but that's what it means. Okay? So the limit that we were given is equal to the limit of, here's where L'Hopital's rule is applied, the limit of derivative of the top, put it on top. Derivative of the bottom, put it on the bottom. Do not use the quotient rule. L'Hopital's rule is not the quotient rule. The derivative of the top is 6f prime of x minus 3. The derivative of the bottom is 2x minus 5. Sometimes we have to use L'Hopital's again. So let's see if we have to this time. If I put 2 into the bottom, I do not get 0 on the bottom. That tells me I am not going to have to use L'Hopital's again. So I'm just going to put equals 6 times f prime of 2. We're going to go to the graph of f prime. F prime at 2 is 0. So 6 times 0 minus 3 divided by 4 minus 5. Safe stop. We're done. It said to justify our answer. What we did at the beginning was our justification for using L'Hopital's rule. Part D. Find the absolute minimum value of f on the closed interval from -2 to 8. -2 to 8 was our interval. So, absolute minimum value of f. Candidate's test. Candidate's test. Our independent variable is x. We're finding the minimum value of f. Remember, you guys, when you are justifying an answer, you have to have headings on this table here if you're going to use that as your justification, which you very likely are. Okay? So make sure you put headings on this table. Okay, we start with our candidates. 2 of the candidates for x are the boundaries, -2 and 8. So I go ahead and put my boundaries there. And then the other boundaries are when f prime is 0, right? F prime is 0. At x is equal to, this is the graph of f prime, it is 0 at -1, 2, and 6. -1, 2, and 6. However, we're looking for an absolute minimum. Could this be an absolute, could x equals -1 be an absolute minimum of f? F prime is going from positive to negative. F has a relative max when x is -1. So I could put -1 as a candidate, but it is not necessary because that would create, well, I'll tell you what I'll do. I'm going to put -1, 2, and 6 here, but I'm not going to find the f value there because it is a relative max. And x equals 6 is neither a relative min nor a relative max. We said that in part A. So could this be an absolute minimum value? No. So not a relative min. The only relative min x value of f is 2, where f prime changes from negative to positive. It would not hurt to complete this using the -1 and the 6, but I already know that those are not going to be my answers. Okay? Alrighty, so now it's time to find f of -2, f of 8, and f of 2. We know f of 2. f of 2 is 1. So now all we have to do is find f of negative 2 and f of 8. So how are we going to find f of negative 2 and f of 8? I think I'm going to find f of 8 first. I want f of 8. I know f of 2, and I have the graph of f prime. We're using the fundamental theorem. F of 8 minus f of what I know is the integral 2 to 8 of f prime. Fundamental theorem. I'm going to use signed areas under the curve for the integral, and I'm going to add over the f of 2 value. So f of 8 is 1 plus, okay, 2 to 8. 2 to 8. So for that, 2 to 8, we always use the x-axis as one of our boundaries. I need this area that I just highlighted. I need that area. So how are we going to get that area? Well, I'm going to split this into two pieces because this is 2. 1 plus 2 halves. That's 2. So that piece is 2. And now for this piece, this is let me mute my phone here. Sorry. Okay. This whole thing here would be a rectangle. It's a rectangle with a semicircle cut out, and whatever is remained, that's what I want. So it's a rectangle of area 8, and I'm subtracting out the semicircle of radius 4, right? So 8 minus a semicircle of radius 2, yeah? Radius 2. Okay, so this would be 11 minus 2 pi. Oops, that was 8. I put that under the wrong one. Okay, for negative 2 now, we're going to do the same thing with negative 2. I want f of negative 2. I know f of 2. So I'm going to set up fundamental theorem. F of 2 minus f of negative 2 is integral negative 2 to 2 of f prime. Okay, f of 2 I know is 1. Now I use the signed areas from negative 2 to 2 to get that value of that integral. So now we're using this piece. So remember, you guys, the x-axis is always a boundary. So we have this and we have this. Okay? So here's how I would find this area. This region is half of that rectangle. It has area 1, but it is the same as this region, but one is above the x-axis, one's below the x-axis, so those two cancel each other out, and I'm left with this region below the x-axis of area 2, 1 plus 2 halves. So negative 2. Okay? I'm going to add f of negative 2 to make it positive. I add this 2 to make it a 3 over there. So f of negative 2 is 3. So now, now we want, which is the minimum value? Which is the minimum value? Which of these is the lowest? Well, I know it's not 3. Is this bigger than 1? Pi is about 3.14, right? 2 times that is 6.28. 11 minus 6.28 is bigger than 1. So the minimum, they're asking for the minimum value of f, not the x value, the value of f. The minimum value of f is 1. Okay, how did they score this problem? Let's see. For part A, this was worth 1 point for the answer with reason. 1 point. For part B, 1 point for the intervals, 1 point for the reason. Now for what they said was in their notes, they said that you could not get credit for the reason if your answer was wrong. So if your intervals were wrong, you lost both of these points. It was worth 2 points. Part C, that was the limit. Part C, 1 point for the limits of the numerator and denominator separately. Okay, that was what we did first. 1 point for uses L'Hopital's rule. Okay. And they clarified that when you use L'Hopital's rule, this had to be correct. The limit of the derivative of the numerator and the derivative of the denominator had to be correct to earn that point. And then the last point was for the answer. So 3 points for that limit. That leaves 3 points for part D. For part D, let's see, 1 point for considers f prime is equal to 0. Okay, did we consider f prime is equal to 0? Yes, we did. So what if we had put these numbers down without saying that? If we had put these numbers down without saying that, we would not have earned this point. Okay? What you're doing when you're completing an FRQ is you are communicating your process. And if you just slap some numbers down here without saying why, you will never earn full credit. Okay? So say what you did. Say why you're doing it. 1 point was for the justification. 1 point was for the answer. 3 points total. Okay, several for you to practice on.